So now we're going to move into the part where we're going to be looking at notebooks. So we've got this GitHub repository that's publicly viewable here. It's github.com/EileenRMartin/intro to DAS data. I'm going to copy this link into the chat for everyone if you're not there yet. Oh, sorry, I got an extra character on there. Just ignore that closed bracket. But when you're here, we're going to look at the Brady Hot Springs data first. So I'm going to click on bradyhotsprings.ipynb, and it's going to open up a preview of this IPython notebook here. So we've got a mix of text code. It's got all the outputs from last time I ran it. And I'm going to open it in Google Colab. So I'm going to click on this logo here with the blue and the yellow kind of figure 8. And this is going to open up the notebook so that it can run on Google Colab servers. So this isn't running on my laptop. I'm just viewing it from my laptop through my web browser. You can see it's got this kind of outline of the table of contents. And I can also click on files over here. So to make sure that all of my old variables from other times I've run this are totally reset and cleared out, I'm just going to do factory reset runtime. Really, it shouldn't have been saving anything from old runs anyways, but let's say if you had a tab open that from earlier with this notebook already, because I know many of you have already tried them, then this will totally reset what's in there. So we're starting from a blank slate. So the Brady Hot Springs experiment is really exciting. It was done in Nevada at this geothermal site. They had fiber optics that were deployed throughout the near surface in sort of a zigzag array. And then they also had a well with data there. So here's a really nice photo that Dante Fratta took. Dante's one of the co-organizers. He and Herbert Wang were also some of the scientists who were helping lead this experiment. Overall, the project, the Porotomo project, was led by Kurt Weigel at University of Wisconsin. And so they've actually done a lot of work on this already. So if you want to dig into this data, check out all of these references. There was also a recently released sort of final report that's pretty comprehensive. So I'd encourage you to take a look at that. So next up, as we're getting our environment set up, some of you might be running this on your own local laptops, but most of you are probably running on Google Colab. And we've got a bunch of packages here. We're going to have NumPy, Matplotlib, OBSPy, SciPy, CSV, widgets to have interactive plots, and GDown to grab big files from Google Drive. So first, let's go ahead. We're going to install OBSPy and GDown. Most of you are going to see this notice here, and we'll run it anyways. So we'll just wait a little bit while that's running for all of you. Probably this is going about the same speed for everybody. It doesn't really matter what your internet speed is because everything's just happening on Google Colab servers. So for those of you stuck at home with slow internet like me, that's really nice for us. All right, so we've got that installed now. Now we're gonna set up all of our Python packages that we need. Now we're going to go ahead and pull the file that has the geometry on it. So the original file is on the geothermal data repository that DOE runs, but we've actually hosted a separate location on Google Drive to make sure that having a couple hundred people access this file at the same time doesn't mess up any of the servers. So I'm going to open up my files section over here, and you can see that if I look at that folder logo and then what's in here, I now have this surface DAS DTS UTM coordinates. So once you get here into the files, you can see that that's been downloaded. So I'm going to close that. And we're just using that wget command like you would at the command line on your own laptop to grab files. All right, now we're going to read the geometry out of that CSV file. So go ahead and run that. Then, once I've got that run, I'm going to look at the location of each of these channel locations relative to where I have a ViberSize source, because we're going to open up a file where a ViberSize source went off and it was recorded by all the other sensors. So I'm just going to calculate what's the distance from there, just a simple plot. And most of you made it through this probably if you worked through that basic video. Okay, so now we're going to make a scatter plot with X and Y locations that we read in from that CSV file, and it's going to be colored by what our channel numbers are, so we can tell where the different channels are in the array. Right, so now we see this is like the aerial overhead view of the Brady Hot Springs array, starting at our low numbered channels and going up to our high numbered channels. So it kind of has small zigzags and bigger zigzags. And this is a really cool kind of setup because it lets us play around with looking at how does that response change with distance, with angle, between the source and the receivers. And note that these are UTM coordinates. So each one of these stretches of these little zigzags, these actually have like dozens of channels within each one of the stretches. So it's not like you're just changing channels every single time you have one of these zigzags. You have a whole stretch of channels that you can analyze in a straight line together. All right, so before we move on to actually grabbing any data, I think this is probably a good place to take a pause and make sure, do people understand the geometry and the notebook setup?
And make sure you can put in any questions in the chat there.
All right. Sounds like we don't have a lot of specific questions. Just to make sure, if anybody ran into difficulties on setting up the notebook, we've put in some padding time here just to get everybody up to speed and on board. So feel free to keep putting questions into the chat during this time. But I think we can move into a break. So you can ask questions, yeah, like Nate says, in the coding environment Slack or here in the chat. So it looks like there's one question: permission denied when downloading data from, so just ask for clarification from Malcolm and Lizzie. Are y'all getting the permission denied error when you're doing the CSV file that you're reading? Or is it during actually pulling the seg-y file of data? Okay, so it looks like during the seg-y file. Okay, for those of you who are getting this error during the seg-y file that you're grabbing, is anyone getting that error on the seg-y file where you're running it through Google Colab, or is this happening just on local laptops? Okay, so people are getting this through Colab. Thanks for those responses. All right, so going back to questions on just the stuff up to geometry files so far, it looks like some people were getting that geom data unsuccessful. So I would say it could be that we need to have people try again over this like more extended break. So those of you who were able to get the geometry data file to work, during this next, like between now and 1:15, go ahead and try to get the seg-y file. Hopefully by like spreading it out over that time, we can have fewer requests into the same file location. I'm wondering if maybe by having a bunch of people trying to read the same file from Google Drive, even though their documentation says it should support tons of people accessing the same file, whether there could be an issue because it's a larger file and we're using the gdown service instead of a normal smaller file that we could just do through wget. So I'm just gonna have people try to do that again over the next like 10 minutes. And if you go through multiple successive attempts and aren't able to get it still, go ahead and post messages there. There is one question on geometry in general that I think it's by Haley Karbala Ali about, is it common to have negative channel numbers in the geometry file? So that is what you should expect there. I'm gonna switch to a different screen. So if I open up this CSV file, it does have negative channel numbers, and then it's got a bunch of channels that are just sort of just junk channels that we're gonna ignore. There's a little bit of bookkeeping in the notebook when we read the geometry that you'll see that takes care of that. It's only here at row 53 that we actually start to have channels that we care about and the geometry written there. So I hope that answers that question. Okay, so all right, looks like some people are having these issues with the downloads. So I'm gonna let people keep adding information in there about like if you're able to access it or not. In the meantime, let's go ahead and we'll do our first break time. So if you are able to access the data, and so at this point, then what we're gonna ask you to do is go ahead and keep adding questions to the FAQ. And then also, if one thing that we want to get is questions that are sort of domain specific. So we got a lot of general questions about DAS in the FAQ yesterday, but you know, there's specific ones about cryosphere, geomechanics, hydrology, things like that. So go ahead and look at those channels and see if you can brainstorm with other people interested in those specific domains to add questions to the FAQ that are specific to those fields.